So, I have the honor to present the last talk, which is a great honor. So I hope I will not spoil the whole event with that. My talk today will be about HP DMF. It's around an implementation we did at a customer site. So it was supposed to be given by my colleague Alberto, which was not able to come. I'm doing the presentation at this space. Also, just want to say that Olaf, my colleague, which is DMF developers, you're free to correct me if I'm saying bullshit, okay? Anyway. So what I'll do here, again, I'll talk a little bit more about DMF, not go into too much, I'll go into some details, but not the same as Olaf. Walk a little bit about the workflow, give some interesting example of what we can do with DMF, which I think we cannot do with Robinhood, for instance. Talk a little bit about how we integrate that with a Ceph backend, okay? So, a few words about technology, introduction. So again, DMF, the idea behind HP DMF is to be the central repository for your data, okay? So this is where all your data and metadata will be. So it's not only working with Lustre, it's supposed to work with every kind of file systems. So far we're supporting a few of them. So XFS, soon to be Spectrum Scale, and Lustre. And then have a lot of backend, as many as we can, to basically store the data in the long term. So it could be tapes, it could be 0-watt storage. I won't talk about this one. I won't talk about tapes either. That's old technology anyway. Or object store. The good things about object store is, this is a new way to store data. What is interesting is object store, especially F3, allows you to store your data as in the cloud, so which is a trend we see so far, and also on premise. Okay, so you can have both ways to store the data, which we think it's interesting. But anyway, DMF allows you to do everything around that. So a little bit of architecture around DMF. I'm sure you know. Most of you knows that already. But anyway, so DMF, DMF version 7 has been designed using big data technologies, okay? So we're using containers, we're using, the framework we're using is Mesos, we're using Kafka for getting logs, we're using NEQ to share a message between the entities, we're using Zookeeper to configure everything. The idea is most interesting of all, we're using Cassandra, the database, okay? So basically we're scalable. We can scale the way we want. We can adapt to any kind of file system, any kind of workload. And we're using also for the any request you might have in the metadata if you want to find a file, we're using Spark, okay? That is a big differentiator about DMF version 7 is we try to be as scalable as possible. Okay. There are, when you're talking about Lustre, there are basically 3 ways to interact with it. Precedent presentation glossed over these things already, but we implement some of those already with DMF. So, you can go through Lustre. So LFS HSM commands, okay, that's standard. We're using the Lustre API to do that. You can also directly interact with DMF, okay? So you can send command to DMF and it will do stuff. Or you can basically try to access a file system that has been offline and that basically will, that's a standard Lustre mechanism, but the MDS will then call the copy tool, which to basically retrieve the file. We've seen that before. So how does it work? Because we're not using the new framework that has been presented just before. We're just using the standard copy tools. So we need to use the copy tools anyway in all cases to fit within the framework of DMF. So the first one, if you want to go through DMF CLI, the idea is you type your command, you go through the DMF job dispatcher, which then use the Lustre HSM API to call the copy tool. We then call back the data management within DMF. Then the copy tool again, so data manager will basically move the data, then copy tool again to interact with the Lustre to get, the Lustre file system aware of the change that has been done, okay, the MDS, basically. If you're using the standard Lustre command, it's a little bit more simple because basically it's standard workflow. So you type your command, or basically you have an action on file systems, going through the Lustre API, copy tools, data management. So basically this is where you move the file, migrate the file, or whatever. And then copy tool again, just to get the MDS aware of what has been done. Okay. Okay, I'll leave that if you want to see more into much details, but this is exactly how it goes. And what is interesting here, so this is all the pieces, all the elements you have within DMF. The important things here is, first of all, as you can see, all the message going on, all the data information within DMF is done via NEQ. And we always go through the copy tool just to stay consistent with Lustre. Okay, so again, when you type a command, you access the type a command on DMF, so that's a direct interaction. So you ask DMF to do something, which go through the job dispatcher, which is then interact with which will spawn jobs, which with DMF copy tools we'll know about, okay, and then which, by the way, will spawn some, add the data mover to move data back and forth, and then come back to the copy tool and come back to the Lustre again. Okay, a little bit more too complex, but the main idea is we really work around the copy tool. Okay, so now that we've seen a little bit the nested details about DMF, so what interesting stuff we can do with DMF? So first of all, there are several ways to install DMF. So either the file system is already existing. Okay, so simple, you put DMF, we scan the file systems. We're scanning the file system, we get all the metadata and put that into the Cassandra database. Okay, simple. Important things is you don't have to wait for the end of the scanning to begin to use the file system and use DMF. Okay, scanning will go on, then you can start using the file system, migrate things. It will work. Okay, if you try to migrate data that has not been scanned already, basically we'll populate DMF with those data. Okay. So even if the scan takes a few days, you'll be able to do that. Another usage is, you have a new file system. If you've been using DMF for some time, you need to change your file system, but you need to repopulate that. We can do that with DMF, which is staging stuff. But the idea is you have a new file system, just tell DMF, okay, populate the metadata, or maybe populate metadata on data. It's up to you. But we'll basically create within a new file system, within the new Lustre file systems, the data that pre-exists. Oops. Okay. Don't want to spend too much time about this because this had been covered already. So DMF for Lustre is using change logs extensively. So we rely on change logs. So as Ola said, we're really sensitive to any problem that can happen with change logs. But yeah, well, this is standard. But so basically, DMF again will use a changelog to mirror any change that happened in the Lustre file system to the Cassandra database and make sure we're on par. Okay. Typical workflow for DMF is as follow. So if you represent, so you have DMF in the lower tier, I would say. You have DMF here with the Cassandra database. You have a backend. We don't care about the backend yet. Could be whatever. Could be tape. Could be storage. Could be S3, so on-premise or in the cloud. We could be all of them. So the idea is, so in the front end, you have some file system. We have one or several file systems. So the idea, again, is DMF is capable of doing a lot of things with a file. So it could, first of all, migrate automatically file that pre-exists, okay, according to policies. So, well, like Robinhood can, I mean, it's nothing new, but without doing anything, you have the policy running, and if there are too many files, or there are files that are, well, if the file system, for instance, is too full, and you have some file that can be migrated offline to the backend file system, it will do that automatically. It can also, on demand, I mean, from user action, move or migrate data back and forth between the front-end file systems on the back-end storage. It could also be used as, well, to populate new namespaces. Okay, so we don't create new namespaces, not with Lustre. With other file systems, we can do that, but not with Lustre, or not yet. But the idea would be we could interact with the job scheduler to basically retrieve files automatically in the front end before a job is run. This is exactly what we're showing here. So it's simple. I mean, you have a job scheduler. Job scheduler can basically create, so it's not only migration, because the metadata might not exist. I mean, you can basically create a new directories on demand. So it will move data that have been stored in the tier storage directly into the front-end file system, the active tiers. I'm messing this one. Okay. And then then the job will rerun. So for Slurm, actually, so we'll do that. Let's say it's Slurm. It will run the job on that, and then when the job is finished, we'll just move the data back to the backend file system. Okay, on everything in an automated way. So that allows you to basically have a file system that is almost empty, onto, depending on the job you want, basically. Pull your data sets or create some data set that you want for a given job. So it could be a good, a good way to use a Lustre-based flash systems, for instance. So it's basically empty. So instead of recreating every time, I've seen that done by other people here. You can just basically have an empty file systems and move data back and forth according to the jobs that you want to run onto, and DMF can do that. Okay. Some, typical example of a command that you can run in DMF that might be interesting. So you can move, again, the data back and forth, so that's DMF put and DMF get. So DMF put, basically synchronizing a file that is on the file system with what's on the back end. Okay. Get will basically get the files again. You have the concept of staging and destaging, which is really interesting. Destaging is basically, you do that for a file or a set of files, is basically so push the latest version on the back end and remove the file from the file systems. Okay, so the metadata is basically not there anymore. okay? And then you can stage it again at another place or at another file system, as we'll see. So that's a very powerful mechanism that allows you to do many things. Okay, you also can do some search on list items directly from the database. As I said, the staging and destaging mechanism can be used to share data between several front-end. So again, DMF can have several front-end. Could be all Lustre, it could be Lustre and other type of file systems. And the idea with staging and destaging is you could destage some data from one file system and staging it to another one, which might be an interesting workflow for some applications. Okay? Okay, other stuff that it might be interesting for with DMF that we can do. Well, offlining data is basically easy. You can remove data from the front end. So it's a little bit like destaging, by the way. You can remove data from the back end, okay, if you really want to do it. That means you remove data from the database. Oh, something that is important that I completely forgot is also DMF version 7 record several versions of your data. So every time you synchronize the data between the front end and the back end, it will be a new version. Okay, you can keep all the version if you want to. You don't have to, but well, by default it will. And then you can retrieve different versions according to what you want. Okay. On the removing part, can be selective. You can remove only version of given version of the data. But that might be interesting. Also, undeleting data. As we know, users have tendency to do mistakes. Sometimes they can remove data, okay? Knowingly or not. I mean, that can be, well, anyway. So what is great with DMF is even if the data is removed, it's still in the database. I mean, the Cassandra database is completely separated from Lustre. It reflects Lustre, but it reflects Lustre, does not reflect the deletion. Okay, so you can always, if data has been deleted, retrieve the data again, okay, with the staging commands. That might be for the admin a very powerful tool. So if someone comes to you and say, well, I've lost my data because, I did an RM by error, you might be able to remove some version of the data. Again, the data has to be synchronized at one point. Well, I'm here already. Okay, so now that we covered, interesting stuff about DMF, let's talk about an implementation we did at a customer. I cannot name it, but that was an interesting one. So basically, this customer needed to have a full HSM. Okay, they didn't want to go on tape for whatever reason, so we decided to go with DMF. That will provide the data movement between the front end and the back end. On the back end, we went for an object store, okay, which gave us the performance. So if you compare it to tape, basically, this will have the performance. It will have the resiliency on the reliability of an object store, okay. On both, also the important things about using an object store in the back end. So it's expandable, okay. It's also, you can make it as fast as you want. Okay, so basically the solution we implemented looks a little bit like this, okay. So with several file systems in the front end, then the HP DMF on Ceph on the back end, okay. Something that is not shown here, the customer in the beginning did have, so there were two clusters, but the customer was using GPFS, the first file system. So we did something interesting, which I don't think it's shown in my slides, but we also use DMF to basically migrate the data. So as I said, the idea was just to to have the both file system in the front end, to scan what was in the GPFS, and then put that in the back end and copy that onto Lustre at the same time. Okay. So the implementation of Ceph we used were the SUSE one. No particular reason for that. I mean, no technical reason. What is important is for those who don't know Ceph, so basically Ceph is an object store. It provides several type of interfaces. So one is POSIX, FFF, the other one is block, and the last one is S3. So with DMF, we're using S3. Why that? Well, block is not so much interested in our case. We don't care about block storage. POSIX also isn't, well, it could be, well, is not, it's not relevant for the back end, okay? We're not so much interested in POSIX in the back end. It might be interesting in the front end, but not for the back end. S3 on the side is, as I said, what's most important thing about S3, it's compatible with a range of products, some being on-premise, some being in the cloud. So this is what we're really interested by SUSE. Again, DMF does support other type of implementation of on S3. It could be based on Scality. It could be based on whatever product is offering an S3 interface. Okay, which it could be Amazon S3 or whatever. Okay. Again, why object storage? It's here. Why Ceph? Because it's open source. Because it's also more and more used, and because it's very stable. Okay. So we did implement some this stuff. We did a lot of testing, a lot of benchmark, and I just wanted that will finish my talk. Just want to present you some benchmark number we got. So again, one thing that is important is Ceph. If you want to do S3, you need something that is called a Rados gateways. Okay, that's basically, so you have the, well, I don't know if you can see it here. You have the object store, with the other storage node, which is here. Well, you have the monitor that basically makes sure that that makes sure that all the storage nodes are healthy. Let's put it that way, and correct or detect any problem within the storage node. And then, in front of that, you have some Rados gateways, which basically are gateway that translate from Ceph object store, which is internal stuff, into Amazon S3. Okay, that's basically a translator. Okay, as you can see here. So, coming back to here, what we did is did some benchmark using two Rados gateways. So, on an object store. So again, that was for that project. On two data movers on DMF. So again, that means two instances of the containers within DMF to do data movement. And we did some experiments. Okay, so as you can see, there are several parameters. Not very interesting here. What is interesting is the performance we got. So basically, that was one data mover and one Rados gateway is capable of doing around 2 to 3 gigabytes per second on a 100 gigabits link. So that's okay. The good thing is that's scalable, as we've shown here. So that's another benchmark we run. That was actually in the customer cluster. Okay, so it's basically addressing the F3. It's the performance when we increase the number of F3 gateways that we're using. So basically, the good thing is it's completely scalable. So the thing, what we discovered, we're expecting that, but basically both DMF and Ceph will scale as long as you increase, so for Ceph, the number of F3 gateways, and for DMF, the number of data movers. Okay, which make it a very interesting solution for really big HSM solutions. Okay, well, I'm almost on time. So, is there any question?
Hello. Do you store the files like as they are on Lustre as single objects in S3? I'm interested, or do you like chunk them up into fixed size chunks?
Yeah. So as far as I know, again, I'll correct me. Basically, there is chunking. I mean, basically, if the file is small enough, it will be put into one object. Okay. So there are different type of objects. One S3 object, which will be several Ceph objects. Okay, because basically by default a Ceph object is 4 megabytes, so it's very small. In the thing we did here, we did use. I mean, DMF did use 256 megabytes object, S3 object. So there is a double mapping. Okay, but so if the file is small enough, yeah, it will be one object, one S3 object. If it's bigger, then it will be chunked. We recommend chunking because it means you can do it in parallel, okay, having several threads pushing the chunks together, so it means better performance. Okay, but that's an option in DMF.
And I mean, sort of related to that, I was wondering, like, if you know how it works, if you did have like a large small file workload, which, like, kind of thinking of Olaf's talk about the tape system, when you have this abstraction you were kind of thinking about with zones, like, is that even similar for S3 and object stores, or can you just treat the latency as being low enough to, just to put small files into their own objects and don't think about bunching?
That's a really good question. I mean, for that customer, we didn't have small files, not as many. That was not a concern. That definitely becomes a concern if you have a file system. A Lustre file system was a lot of small files. But then, as I said, DMF can have several backend. What we recommend is, if you come here, I don't have any. I think that's the first slides. Yeah, this one. There is another backend which is called 0-watt storage. Basically, a bunch of drives. JBOD. It's basically a JBOD where we treat disk drive as tapes. Okay. The good thing is, so you can have both of them, and we do recommend actually, if you have a lot of small files, on DMF can do that based on the size of the file you want to archive. Move the file directly to the. I mean, if it's a small file, put it on the 0-watt storage. Or if it's a big file, put it on the S3. Okay, that would be the recommendation.
Great, thanks.
Let's say we have two file systems,
okay,
and let's call it A and B, and A has been migrated to B. Do you provide any mode to keep it synchronized?
No.
Okay.
No, so you can do what we call transversal movement. I mean, as I said, move data or move set, a number of files from A to B. But then what we recommend is when you do that, either you're keeping several versions, so you basically duplicate your files, or what you do is this stage on one side and stage it on the other sides. Okay, because otherwise, I think it would be too complex to keep track of every change back and forth. Okay,
yeah.
So this mechanism is not to have same application working at the same time on both file systems. You have to think it as a workflow, a pipe. So you need to do some treatment of some data. You need a specific file system for that. Let's say a flash-based file system. So you put the data there, and then when it's finished, you can basically script it with DMF. So move the data on the other files. You still keep it in the same database. So it's still being tracked. And then you do the rest of the processing on a standard Lustre, let's say. Just an example. So I don't know if it's answer your question.
I thought something like I want to migrate A to B,
yeah,
and still I'm working on A, but the changes should go transparent way to B. Then in the end I can switch to B and drop A, for example, would be a use case.
Okay, so no, because basically what will happen is when you move from, well, when you do the movement, the data will not be available. After the movement, the data will not be available anymore on A.
Could be a case where I
Okay. If you want to do that, if you really want to do that, then you'll use staging again, because staging basically allows you to have several copies.
Let's say I don't want to have several copies. I just want to have it synchronized.
Okay.
Imagine we have hundreds of users and we can't keep control easily that it's consistent in the end. And that's why I'm asking.
Yeah, well, the thing is we can prevent, so if you, well, what I don't understand is, are you afraid to lose data, or do you want?
No, the use case would be you have two file system installations, and you want to, in the future, to use installation B because it's newer. But you also have to transfer the data from A to B. So in the end, you can tell the users, okay, tomorrow B is active and productive, forget A. But for that, you have to keep it synchronized. And the user don't have access to B, for example.
Okay, so yes, you can do that. That's a more complex thing. Okay, if it's a migration?
It's more than that. In the end, yes, it's a migration, but you have to keep it synchronized.
So what will happen, again, it's a more complex scenario, but what will happen is, so since the data, it will take a long time to populate B. Let's say it's several petabytes. Okay, so what you'll do is you start populating Bs while A's, users are still working on A. When you say, okay, well, after this time you should use B, that means at that time you'll basically push the deltas.
The delta, yes. In the end, you have I think you have a delta. Then it depends how fast this framework is to synchronize the data.
Yeah, well, basically the delta will be known by DMF because it will track.
That's the question. If it's known, then you can say, okay, we have a
we can do that.
Window, and then we synchronize it.
We can do that. This is done for, working on such scenarios for some customers.
Okay, thank you.
Okay. Okay.
Okay.
Thank you.